Welcome to The Explainer. Today, we're going to break down the fundamental rules that make the internet even possible. You know, the invisible architecture that's literally letting you watch this right now.
So let's kick things off with a huge question, one that you probably don't even think about most of the time. How in the world do billions of different devices made by completely different companies all manage to speak the same language online? Seriously, how does your iPhone in, say, Japan, talk seamlessly to a server sitting in Brazil?
Well, the answer is this amazing universal rulebook called the TCP IP model. You might also hear it called the DoD model, and that's because it was actually created by a U.S. defense agency called DARPA. See, they had this problem. They needed to build a computer network that was so decentralized it could survive a major attack. And this model, this was their brilliant solution. It's basically the universal language for all internet communication. Okay, so to really get a grip on the model we use today, we've got to go back in time a little bit. Let's take a look at its original, simpler design, the blueprint that really started this whole revolution.
So this first version, it had just 4 distinct layers, and each layer had a very specific job to do. Handling the data as it moves from whatever application you're using, think your web browser, all the way down to the physical connection itself, like your good old Ethernet cable.
But you know how it is. Technology never stands still, right? As networks got way more complex, it became pretty clear that the model needed a bit of an upgrade. It needed to be more precise, more clear. And listen, this change wasn't just for looks. The new 5-layer model gives us a much more detailed and, frankly, more accurate picture of what's really happening under the hood when data gets prepped to be sent out. The big thing it did was separate concepts that used to be all jumbled together, and we're going to see that right now.
And here it is. This slide shows you the key change perfectly. See that bottom link layer from the old model? Well, it got split into 2 distinct layers, the data link layer and the physical layer. Now, this was a huge deal because it finally separated the how of addressing, the logical part, from the what of the physical connection, the actual electrical signals zipping through the wires.
Oh, and check this out. This is a pro tip for any of you out there studying for networking certifications, like a Cisco exam. This right here is a golden nugget of info. It seems they pretty much always prefer the 5-layer model in their questions. So yeah, it's not just more accurate in the real world, it's exactly what you need to know to pass those tests.
All right, so we've got these 5 layers, but how does your data, your email, your video stream actually travel through them? Well, there's a process for that, and it's called encapsulation. And let me tell you, this is one of the most fundamental concepts in all of networking.
The easiest way to think about it is like a postal service. Seriously, your data is the letter you wrote. At one layer, you stick it in an envelope with some basic info. Then, at the next layer, you put that envelope inside another, bigger envelope with a different address on it. Each layer just keeps wrapping the package it gets from the layer above, adding its own special instructions for the journey.
Okay, and this table really lays out that entire journey step by step. Just look what happens as your original data moves down through the layers. We call that moving down the stack. Each layer tacks on its own little wrapper, which we call a header. And get this, the name for the whole chunk of data actually changes at each step. What starts as just data at the top becomes a segment, then it's a packet, then a frame, until finally, at the very bottom, it's not even a thing anymore. It's just bits, the actual ones and zeros that are going to travel over the cable or through the air. Okay, so to put all this into a bit more context, let's see how our very practical, real-world TCP IP model compares to another famous framework. This is one you will absolutely hear about if you ever take a networking class. So, while TCP IP is the model the internet is actually built on, it's always being compared to something called the OSI model. Now think of the OSI model as this super detailed 7-layer theoretical framework. It's fantastic for teaching, for breaking down concepts, but when it comes to what's running the show in the real world, it's TCP IP all the way. And understanding how these 2 models map to each other is super important. The biggest thing to notice is right at the top. See those top 3 layers of the OSI model? Application, presentation, and session? In the TCP IP model, they're all just squished together into one single application layer. It's way more practical. After that, though, the rest of the layers map pretty cleanly, almost one-to-one. All right, so we've gone through a lot of technical detail here. Let's pull back and zoom out for a second. Why does any of this actually matter? What's the big picture? Why should you care? Look, this isn't just some abstract theory for a textbook. This is the very engine that makes your entire digital life possible, from the emails you send, to the websites you browse, to the videos you stream. It's the reason a Samsung phone can talk to an Apple server without a problem. It standardizes the whole complex process of data transmission. And yeah, if you're even thinking about a career in IT or networking, this isn't just nice to know, it's absolutely critical, foundational knowledge.
So think about it. Every single time you go online, every click, every search, you are relying on this incredibly elegant and robust set of rules working flawlessly, totally invisibly in the background. It is truly the unsung hero of our connected world.
And that brings us to a final thought, something for you to chew on. We've seen the model already evolve once, right? From 4 layers to 5. So as our world becomes even more connected, think about all the AI and billions of new IoT devices coming online. What do you think the next evolution of this model is going to look like?